All right, so yesterday you were asked to study the table and come up with some what do you notice, what do you wonders. I know that me looking at this, I definitely noticed a couple things. In the X's, it's 0, 1, 2, 3, 4, 5. So to me, the X's are increasing by 1 each time in the table. And then if I look at the Y's, this is 0, 16, 64, 144, 256, and 400. I notice that these are all what's called perfect squares. 16 is 4 squared, 64 is 8 squared, 144 is 12 squared, 256 is 16 squared, and 400 is 20 squared. So I noticed that as well. I'm not sure how that is helpful in the chart, but those are the things I noticed immediately. And then something I wonder is, how is this helpful for this graph? This table. What is this table trying to represent? So here's some things that you may have noticed. The X values increase by 1. The Y values increase. The Y values are all even and divisible by 4, 8, and 16. The numbers are all perfect squares. The successive differences are growing. So what that means is when you take the differences here between 16 minus 0, 64 minus 16, they're growing, they're increasing. Things you might wonder is there a rule for these numbers? Do the numbers represent the growth of a geometric pattern? Do the numbers represent a quadratic relationship? And what is the next number in the table? Those are some things you may wonder. So next we had this one. A rock is dropped from the top of a rock is dropped from the top floor of a 500-foot tall building. So they give us the building, and then on the right of the building, we see it says 0 seconds, it fell 0 feet. That makes sense. We haven't even really dropped it yet, then it shouldn't have fallen. At 1 second, it's already fallen 16 feet. At 2 seconds, it's fallen 64 feet. 3 seconds, it's fallen 144 feet. 4 seconds, it's fallen 256 feet. And at 5 seconds, it's fallen 400 feet. So the first question asked is, how far will the rock have fallen after 6 seconds? So if you're like me, you might actually try to determine this based on some type of reasoning. Otherwise, if you weren't exactly sure what you were looking at, but you were like, okay, I see some type of connection here. 64 minus 16, if I do 64 minus 16 to see how much the rock dropped between seconds 1 and seconds 2, I see that between second 1 and second 2, it fell 48 feet. If I want to see what happened between the second and the third second, I'm going to subtract 64 from 144. And I see that now in between these two, it has fallen 80. Then looking at second 3 and second 4, between these two, 256 and 144, I see that it has fallen 112. So here 48, here 80, here 112. And now, let's see, between 400 and 256, it's going to have fallen 144 feet. Well, it just told me before that this building is 500 feet tall. So if this building is 500 feet tall, from the base of this building all the way to the top, that means that from here at 5 seconds to here, the base, is only 100 feet. So my answer, without really using a lot of math, just looking at it and reasoning through the picture, I would say that it has fallen 500 feet for sure. Because after 6 seconds, it might be down here, right? Obviously, the rock is not going to go in the, the ground. It is going to stop here. But when we see this and we know that from here to here is 144 feet, it's not going to be smaller here. We see it's increasing from 48 to 80 to, what was it next? 112 to 144. So here it's going to be probably a lot higher, and therefore at 500 feet. And this is something that you could have said. 500 feet. The rock would hit the ground before 6 seconds. The distance fallen increased with each additional second. The rock fell 144 feet between 4 and 5 seconds. So between 5 and 6 seconds, it would fall more than 144 feet. After 5 seconds of falling, there is less than 144 feet to go before the rock hits the ground. Okay, so that just sums up what I just said. For number 2, it says, Jada noticed that the distances fallen are multiples of 16. Interesting. So they're all multiples of 16. Let's see. So, okay, that makes sense. 16 times 1 is 16. 16 times 4 gives us 64. 16 times 9, 144. 16 times 16, 256. And 16 times 25 gives us 400. This is the part that really intrigues me, though. It says, then she noticed that 1, 4, 9, 16, and 25, the numbers that are given to us right here, 1, 4, 9, 16, and 25, are 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared. So those numbers are increasing in increments of 1, even though they're being squared, so it's truly not by 1, but the number that we're squaring, 1, 2, 3, 4, those are increasing by 1. So if I were to predict something, I don't know. What would I predict? So the next thing says, use Jada's observations to predict the distance fallen after 7 seconds. And we're going to assume that the building is tall enough that the object dropped from the top and will continue falling for at least 7 seconds. So just ignore the fact that we know that over here it said it was 500 feet. Now we're going to imagine that it's, 800, 900, 1100 feet. So if I'm going to use her observations to predict something after 7 seconds, well, we would have to do something after 6 seconds first, I would imagine. So if it's telling me that 5 seconds is 16 times 25, and they get that because it's 16 times 5 squared, what I really need to do here is 16 times 6 squared and see what that's going to give me. And 16 times 6 squared is 16 times 36. So we're going to see what's 16 times 36. So that's 576. So now we just proved that our answer from 1 was correct as well. But it's not asking me what's happening after 6 seconds. That's asking me what's happening after 7 seconds. So now I'm going to move on to times 7. 7 squared. And if you remember, 7 squared is 49. 7 times 7 is 49. So now I got to do 16 times 49, and that tells me 784. So using her observations, I'm going to predict that it's at 784 after 7 seconds because of the fact that we kind of noticed that it was going down in multiples of 16 being multiplied by a perfect square, or something squared, excuse me. So then B says, write an equation. Well, actually, let's check. Okay, so there we go. 784, see? 16 times 7 squared equals 16 times 49. Cool. Now it says, write an equation for the function with D representing the distance dropped after t seconds. So D is representing the distance dropped after t seconds. So like D of t maybe, depending on the time, we don't know which second it is, would be 16 times t squared. So some of you watching this might be like, hold up, where did she just get that from? I'm literally looking right here. I know 16 has to be involved because each of these has 16. This column represents D, the distance. And this column represents t, the time. After 1 second, after 1 second, after 2 seconds, after 3 seconds, after 4 seconds, and after 5 seconds. You just have to remember that that number was squared, and that's why I have t squared. So this, I should actually say that column represents t squared because it's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And that is where I'm coming up with this. So let's see if I'm correct. Well, there you go. D equals 16 times t squared. Hopefully you were able to see that. Make sure you go back and rewatch this video if you have any additional questions, and just pause throughout and hopefully they'll be clear. If you're still a little confused on this, make sure you come to office hours or send me a message. Thank you.